Let's refresh ourselves. Friday we talked about parallel lines. Are these two parallel? Would these two lines be parallel? BB Brody Boyd says yeah, because why?
The slopes are the same.
Perfectly said. The slopes are the same. You guys, how about this one? Y equals 2x plus 3. Y equals 1/2 x plus 5. Parallel?
No.
Perpendicular? No. What would I need to do to one of them to make them perpendicular? Yeah, could I do it over on my 2? Yeah, totally could, because then they're negative reciprocals. Love it. Y equals 2x plus 3 versus 2y equals 4x plus 6. Parallel, perpendicular, coinciding, neither. Coinciding, Chloe, you said coinciding. How'd you know that, girl?
Because if you divide both sides by 2, it's the same.
It's the same. You guys, this Tuesday, y'all are on. Okay. Write the point slope form. Oh, yeah. Let's remind ourselves of this on this Tuesday morning. Braden Fink, do you think that you remember point slope form?
Not exactly.
Okay, then maybe we should zip it up. Point slope form. Y. Oh, so right. You're so right. Equals m x minus x1. So good. That's our point slope form. Boom. Okay. Here's our point. They want it through that point parallel to this line. What do I need to get from this line? The slope. How would I do that? What do we want to do first? Do we want to subtract 3y or subtract 4x and add 7? Doesn't matter. I heard subtract 3y, so we'll go with it. So you're saying we got 4x minus 7 equals a negative 3y. Be very careful about dividing by that negative. What would be my slope? Negative 4/3. And then don't forget to put that x. And then we're going to say plus 7/3. And the 7/3 really doesn't apply for what we need from this. But perfect. As Ben said, our slope is negative 4/3. If they want it parallel to it, you guys, are we going to keep it or change it? We're going to keep it. So what's going to be my point slope form? Ben Richardson, you got this. Y minus y plus 1, he said, equals my new slope. Negative 4/3 x. Perfect, you guys. Here we go. Determine the equation of the perpendicular bisector of the line segment with these two endpoints. You guys, a couple different ways we could do this, but I really brought this up kind of because of the ACT. Perpendicular and a bisector. Perpendicular, we've been dealing with those slopes. We know that they're going to be negative reciprocals or opposite reciprocals. And it's that they want the equation of this dotted green line. I know it's not green on your sheet. The equation of that line that's not only perpendicular to this blue segment, but also bisects it. Thoughts on where we could start? Again, there's multiple ways we could do it. We need a perpendicular and we need bisector. Which one do you want to start with? Okay, if we're going for the slope, do you think we could find the slope of this blue line and then go find its perpendicular slope? You guys, do you want to do change in y over change in x? You totally could. Or do you want to do rise over run? Either way, because we've got the graph in front of us, I'm good with either one. What do we feel like? We change in y, Aiden, you make the call. Do you want to count rise over run or do you want to do change in y over change in x? He said, let's just count it. All right, Aiden, just be careful. Check this out. This goes 2, 4, 6, 8. So when we rise, we got to count that, right? So we're going to go 2, 4, 6, 8, 10, 12, 14, it looks like. So my rise is 14. Over, is it the same scale on the bottom? It is. So then I'm going to make sure that I go over 2, 4, 6, 8. We're all the way up here. And then we're going to go over 2, 4, 6, 8, would you say? What would that slope simplify to? 14/8. Thanks, 7/4. Now, if you're like, oh, I would have just done change in y over change in x, that would have gotten me 14/8 again. So either way, right? Doesn't matter which way we do it. We're getting the same slope. Oh, I also wanted to point out, when these axes match, look what I could have also done, Aiden. Because they both go up by 2s, I could have counted just by 1s. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. Up 7 over 4. So, okay, you guys, we got the perpendicular slope. We got to get a point of this green line. We got to get a point. It's got to bisect this blue segment. Ooh. Say that again? Oh my gosh, Hayden, boom. He said find the midpoint. You guys, again, couple different ways you could do that. We could find the average. You really could eyeball it, truly. And/or, does anyone remember that midpoint formula? Midpoint is just an average. What do you do if I give you two quizzes back and you wanted to find your average? You add them up and you divide by 2. Exactly, Tegan. So for the midpoint, you add the x's up and divide by 2, and then you add the y's up and you divide by 2. Let's add those x's. What are my x's, you guys? Three and 11, I heard. 3 plus 11 over 2. What are my y's? 18 plus 4 over 2. Let's do this mental math. 11 plus 3. 14 divided by 2. 7. 18 plus 4. 22 divided by 2. Boom, there's our point. Thanks, Teague. So you guys, can we write the equation in point slope form, because that's what we're doing this year, with my slope that's, perpendicular to this blue one. The blue slope was 7/4. What's the perpendicular slope going to be? Nice. -4/7 is the negative reciprocal. And then we're going to do y minus my y coordinate equals my slope of x minus the x coordinate. There we go. This one does get uncomfortable for my kiddos, so I'm going to really try to, tried to rewrite it this year to hopefully help us a little bit. We've got this equation of line M. Why did I use M? Because M looks like slope. My bad. This is just the equation of some line. They said for what value of k in this other line is this new line parallel to my original one? If things are parallel, what do we know about them? The same slope. Can we go get the slope from this? We can do it. You guys, do you want to add 14y or subtract 8x and subtract 3? Add 14y, dig it. So we got 14y is 8x plus 3. Let's go get that slope. What would that slope be? Eight 14ths, what are we going to say that is? 4/7. Perfect. I'm going to move this down a little bit. Y equals 4/7 x. And then it's plus 3/14. Doesn't even matter because we just really cared about that slope. So they said, for what value of k is this graph parallel to this graph? What do these two graphs need to have? They got to have the same slope. So could we go try to get this guy's slope by itself? Let's go try to get the slope. Don't let that k scare you. It's just a variable, it's just taking the place of a number, if you will. So let's just try to get y by itself, just like we did right here. Are you good with adding 7y? Great. And subtracting by 7, just like we did on the other side. What would you say my slope is here? Over here we said 8/14 or 4/7. What would we say here? K over 7. Yeah, I know it's a little uncomfortable. We'd say K over 7x plus 10/7. Again, that 10/7 doesn't really matter. So the slope is always the coefficient. It doesn't involve the x. So for these to be parallel, sorry, what's up, Lo? Can we use some common sense? What would my K be for these slopes to be the same? 4, right? Now, what if it's not glaring us in the face? What if it was an over 7 or any multiple of 7? Here's how we could set it up. You say, well, my slopes have to be the same. 4/7 has to be the same as K/7. When we've got two fractions equal to each other, does anyone remember how we could solve that? Cross multiply, Ben Richardson. We're going to cross multiply it. Yeah. With the next one, we have to do this. So that's why I'm pre-teaching it. What's 4 times 7, y'all? 28 equals 7K. Divide by 7. 28 over 7 is 4. Now, did you need to show that step if you were like, K over 7 has to be equal to 4 over 7, my K is going to be 4. You do not need to show that step, but it won't be as easy on the next part. So I just wanted to set this up because you'll have to do that. Here we go. Last one. What is K if the graphs of M? Oh, let's go back up to here's my M. Here's AM. This one still applies. And this new equation, actually, no, it's the same equation. They're perpendicular. So these same, I haven't changed anything. They just want to know what is K in this same equation. These two are the same. Would K be something different if they now needed to be perpendicular and not parallel? So you guys, what was my original slope again? 4/7, and it needs to be perpendicular to that. What? Yeah. Okay, so do you agree? What is, my original slope was 4/7. What did you say perpendicular to that would be? -7/4. That's the perpendicular slope. And now we got to go figure out what K would be of my slope over here. So I'd say -7/4 has to equal K over 7. Let me say how I did that one more time, because this is where my kids, I lose them. My original slope was 4/7. They wanted to be perpendicular, so I said -7/4. This slope has to be equal to -7/4 for these two to be perpendicular. Can I cross multiply these now? Yeah. What's -7 times 7? -49. Does the negative go with the top and the bottom? No, because if it did, it'd be a -7 over a -4, and a negative over a negative would be positive. So it can only go with one. I always choose the top personally. So then I've got 4 times K on the bottom. What's my K going to be? Just leave. -49/4? Did you try to simplify that, bud? Quick question. What if someone was like, oh, I would have kept my 4/7, that my slope was 4/7, and this guy had to be the opposite reciprocal, -7 over K. If you did that, as long as we flipped one of them, we're still going to get the exact same answer. But I'd say that's what throws my kids a little bit.